Up to this point, all of our queries have gotten information directly from data in a table. Like this query, for example, is pulling in the employee ID, the first name, and the last name fields directly from the table and showing it to you in your result set as information. What about derived or expression fields? For example, if I were to put a comma after this last field and then type first name plus last name and call it full name, we get the first name plus last name in one field. And it runs together a little ugly because I didn't put a space in there, so let me add a space before adding the last name. Rerun the query. Now there is no field in the employee table called full name. It is taking data, concatenating it in what's known as an expression field. Now putting single quotes around the expression field name is optional and not more commonly used. Let's take a numeric version of an expression field. Let's start off with just selecting the product name and retail price from the current products table. Now let's say right now that the exchange rate between the US dollar and the Canadian dollar is 1.1. So let's make a calculation. Retail price times 1.1 and run it. So if the cost is $61.48 US, it would be 67.63 Canadian. This new expression field doesn't seem to have a field name, so let's go ahead and alias this as CND $. Now we can see that that's the Canadian price. Before we change the scaling of our decimals, let's see how SQL Server uses decimals. Both of these decimals would take up the same amount of memory in SQL Server. Why? What do they have in common? Well, both of these decimals are exactly 5 digits long. Now, they're not the same 5 digits. One is 5 digits with 1 decimal point. The other is 5 digits with 4 decimal points. The first one would be referred to as a decimal 5-1. The second one would be referred to as a decimal 5-4. How about another example? We can have more or fewer digits both before and after the decimal point. Here are some examples. The first one is a decimal 2-1. 2 total digits, 1 after the decimal point. How about 14.5? That's a decimal 3-1. 14.45 is a decimal 4-2. 985.1 is a decimal 4-1. And 9982.16 is a decimal 6-2. 6 total digits, 2 of them after the decimal point. One thing to keep in mind about a decimal 6-2 is it could be a 0, or it could go up to 4 digits before the decimal point and 2 digits after. The decimal specification shows how large the number can go. Well, this expression field where we multiplied a decimal by another decimal seemed to have given us too many significant figures. Do we really want our expression field to go down to the thousandth of a Canadian penny or even smaller? Well, what we can do is we can have some control over that by doing a cast. So we will cast this entire operation as a decimal and run it. Now notice the decimal defaults to having no decimal places. We want to set a precision and scale. For example, if I thought the price was going to go up to $999.99, I need to hold 5 digits, and 2 of those digits will be after the decimal. This would be a precision of 5,2. Well, I have several product in the thousands, so I'm going to cast this decimal as a 6,2, which goes up to 9,999. Now we see our results down to just the penny. Let's examine this against a single result. We take the number 3.85 and we round it to 2 decimal places, you get 3.85. Now, if we round it to 1 decimal point, you would get 3.90. Let's take a look. Type select 3.85 and you see 3.85. Okay, let's change this to select round 3.85 to 2 decimal points. And that is also 3.85. What if we go round to 1 decimal point? It's 3.90. What if we go round to 0 decimal points? That goes all the way up to 4.00. If we were to take these exact same functions and look at them with a 4, let's check our results. Select 4 produces a 4. 4 rounded 2 produces a 4. 4 rounded 1 produces a 4. And 4 rounded 0 produces a 4. So the underlying data dictates the number of significant figures, and that shows how far the rounding can go. Let's repeat the cast function we saw in the last lab, but let's keep it in US dollars. Let's type cast retail price as decimal, and then let's do 6,2, and we'll say that's as price. Now what we've done here is we've effectively said we only want 2 decimal points. The original data went to the 10th of a penny, which is not necessary for our business. This 483 rounded down to 48. This 669 rounded up to 67. Now, if you just want to round, there's another function you can use. Place a comma here to start a new field, and then round, parenthesis, retail price, comma, 2, ending parenthesis, and then let's alias this as round to price. And we can see we've gone out 2 decimal points, and it did effectively the same thing as the cast. What happens if we round it to 1 decimal point? Let's put a comma and then round retail price and then choose a 1. Now let's alias this as round 1 price. And notice $61.50, $110.70, $184.40, so it rounds to the dime. Now what happens if I go round retail price and we choose a 0 and alias this as round 0 price? Now run it. Notice we get $61, $111, $184. It rounded the decimals while leaving the significant figures in place. Okay, let's combine a few strategies here. Let's select the first name, the last name, and the hire date fields from the employee table. Now, what we're interested in viewing is all the employees who started with us after January 1st, 2000. Type where hire date is greater than January 1st, 2000. 8 employees were hired on or after January 1st, 2000. Now, what we want instead of first name, last name is the first name, last name concatenation with a space in the middle. We learned this in the first part of the lesson. Now run it. Great. We have our first field, which has first and last name, and our hire date field. Now, our first and last name expression field has no field header, which is probably not a good idea if there's calling code expecting it to have a name. So let's alias this as full name. And then we see our result set. Now, these are all the people hired after the year 2000, but let's see them in order by their full name. We can obviously order them by last name. We see Adams first, followed by Bender, then Brown, and so on. But can we sort them by the expression field of full name? Well, let's try it. Here's the same query. The only difference is the order by is on the expression field. Let's run this. Looks like we can, and it's sorted by the full name. We're going to use a convert function. Type convert n-var char for Unicode variable length characters for the hire date field, and we will use style 101 and run it. And style 101 does month, day, year. Well, what does style 102 do? Oh, that goes year, month, and day. Let's keep it as style 101 and alias this as hire date. And there we go. Now, the original data of the hire date was a date time field with numerics underneath it, And now we've converted it into a character data, and the original name was hire date. The new name was hire date. If we order by hire date, which one does it choose? Let's execute. It should give me the first hired person first. Now, is the year 2000 David Lonning the first person hired? I can see that Barbara was hired in 1995, which was 5 years before David. So why is David listed before Barbara? Because we turned this into character data, and David's 01 sorts before Barbara's 05. So we have an odd character sort, and we have a name conflict. Hire date refers to the expression field, which is the same name as this tables field, which is now not visible to us. It probably would have been a good idea to have given this alias a different name, like hired date or employment date. Run it, and now we are sorting by the original data, which shows the first date first. What if we had to use this name as the expression field? What if calling code was depending on this? What's another way to solve this problem? We want it to be alias as hire date. We want it to appear in this friendly converted format, but we want the sorts to go against the actual field of the table. What's the name of the table? Employee. So let's put employee.hiredate. So if you have a name conflict, you can fix the name conflict by referring to the two-part name of the original field, and you get your sort order with a friendly look and layout of the convert function. Time for Lab 3.2, Skill Check 1. Using what you've learned, make another field to express the price in Canadian currency called CDN $, that is 1.1 times the stated retail price in JProCo's current products table. Then, create two additional fields named Aussie dollar, which is 1.4 times the retail price, and Euro, which is 0.82 times the retail price. Be sure to round all of your expression fields to 2 decimal points. When you're done, your screen should resemble the figure you see here. Skill Check 2. Find the 773 records in your customer table where the customer type is consumer. Show the customer ID, customer type field, and a full name expression field. Your results should be sorted by the full name fields Z to A. When you're done, your results should resemble the figure you see here. Skill Check 3. Join the sales invoice detail table to the current products table. Show product ID, product name, and retail price from the current products table. Show quantity from the sales invoice detail table. And create an expression field called subtotal, which multiplies the retail price by the quantity. When you're done, your screen should resemble the figure you see here. Skill Check 4. Modify your query from Skill Check 3 using the round function. Show retail price and the subtotal expression fields rounded to the nearest penny. When you're done, your results should resemble the figure you see here.